Hello everyone, welcome to Sweetie Speaks official YouTube channel. Today we are at day 35 of 111 days verification challenge. Skill set which we are focusing on right now is Verilog and the topic for today is procedural blocks. We will first learn about some procedural blocks and then also solve some coding examples. Because practicing codes is most important thing to learn any coding language. Verilog is a coding language. Without practicing codes, we will not learn anything. So let's get started with procedural blocks today. One of the very important procedural blocks is initial and always. Whatever design, whatever verification environment you code, initial and always block will always be there. So today let's understand about what is the purpose of these initial and always block. First understand what are these initial and always block, then what is the purpose of these and when is initial used, when is always used. Now, when we are designing an RTL code, we need to think about synthesis because you need to be able to synthesize your code. If it is not synthesizable, it means can't put it, you can't put that logic in your chip. When you are doing verification, then you don't think about synthesis a lot because your verification code doesn't go in synthesis. It's just for your test purpose, but design code needs to be synthesizable. So when we are using initial and always block, we need to think whether this initial and always block is going to be synthesizable or not. So you tell me whether this initial and always block is synthesizable or not. If yes, why? If not, why? Then the next thing which we will see is final block. There is also a final block in Verilog. What is this final block? You need to tell it. Then we have a forever loop. Can this forever loop be stopped in Verilog? Is there a way to stop forever loop in Verilog? If there is a way, tell me what it is. Then initial and always blocks, can they be used inside a task? You need to tell. Inside your always block, you have a sensitivity list. What will happen if there is no sensitivity list? Think what will happen if you just have always block if there is no sensitivity list. Think and then tell me. Then we have blocking and non-blocking statements in Verilog. What are these blocking and non-blocking statements in Verilog? And explain it with the help of example. Write a code for blocking and non-blocking. Explain it with the example and what is the difference between blocking and non-blocking. I'll say them assignments. Blocking and non-blocking assignments in Verilog. So what are these and what is the difference between blocking and non-blocking? Then we have a continuous assignment, which is assign statement. What is this continuous assignment? Explain it with the example. Again, you have to write a code, execute it in the free practice platform like EDA Playground, and then we will move to some codes. There is 8 is to 3 priority encoder. We have seen these priority encoders in digital electronics in the previous day's challenge. Today you will design this 8 is to 3 priority encoder using case statement. There is a case statement in Verilog. Use this case statement and design 8 is to 3 priority encoder in Verilog. Then design delatch, and there is a decade counter. Decade counter means which can just count to 0 to 9, and once it receives 9 it has to reset again. That's a decade counter. So design this decade counter in Verilog. Solve all these questions today and tomorrow I'll see you for day 36 challenge. Best luck.